So here comes the fun part. The really fun part. So we're going to plug in what we found. So our ds squared equals a of r dt squared minus b of r dr squared minus r squared d. We're going to plug this metric tensor into the very tedious. If I make a mistake, I will be angry, but it'll be worth it because it's fun to do. We're going to plug this into our for our various components of our Ricci curvature tensor. We're only going to do the diagonal components. I could work out the non-diagonal components, but to save us time, we'll only really need the the diagonal components for right now. We're going to set them to 0, and we'll have 4 partial differential equations to solve, one for each term. So there we go. All right. So one more thing. I'm going to use this over here as kind of a bank, so to speak, for writing Christoffel symbols. We're working with this is a diagonal metric tensor, so I'm not going to sum over the non-diagonals in here, which Christoffel symbol is this right here. And since our metric tensor is diagonal, our inverse metric tensor components are just 1 divided by those components, which is greatly simplifying. But since our metric components are 0 unless u equals v, which is a great simplifying solution, we're just going to say the sum over lambda. Yeah. So that'll be our Christoffel symbols. Okay, so first we're going to go tediously calculating the r sub 0, 0 component. Let's hope I don't mess up. It's very easy to mess up with this, especially if you've been out in 100-degree weather for 8 hours. Okay, so we're going to hope. We're going to basically sum over each of these. Well, already right off the bat, we know that there's no time dependence in any of this, so our 0 derivative, our time derivative there is going to be 0, so we can ignore that, plus that's going to be 0, 0. All right. Well, let's look at this term right here, this Christoffel symbol. 1/2 GPP E 0, 0 plus, well, there's no time dependence, and that one's the same. Minus G 0, 0. I'm going to kind of just not rush, but kind of just run through some of these. Well, our G sub 0, 0 is A of R, and it only depends on one coordinate, and that's R, so we only need to sum over P equals R. Similarly, G Similar with that one, you only need to sum over lambda equals r. Ooh, that was ugly. And I'll focus on that in just a second. Now we need to sum over all values of p here, which includes all of our metric components. So because G, P, P, G, P, P, R, it'll just be all of our components are dependent upon R, so we'll actually have to sum over all of them. And now this part's the fun part. 0, we gotta sum over all the zeros, all the R's, all the thetas, all the phi's. Okay, so let's use constraints here. We already determined that 0, 0, and lambda, it's only going to depend on r. We only need to sum over lambda equals r there. And r0 plus r0 r. There's no time dependence. R0 terms, that's asymmetric, or that's a non-diagonal, and it must be 0. Only lambda equals 0 will survive that term, or that summation. Theta, and the theta and phi terms are actually quite similar. So there's no theta dependence on anything but 0. There's no time dependence, and that's on diagonal. So these two will go to 0. Erase that. You don't need to point towards this. Just erasing that so we have space. Oops. So our first component of the 4 that we're going to calculate, I'm actually only going to calculate 3 because one's kind of trivial. I could do it, but to save time. That's an R00 term. And those are actually the same terms, so you can just add those together, and that's times 2. Well, you can absorb that into that coefficient, and that's just going to be 1 minus 2 times that. So our R sub 00 term is that right there. I'm going to write that over here for before I do that, I'm going to point out that these right here are actually easy to go ahead and get rid of. So we've defined, this is our first Christoffel symbol we'll actually calculate. So, let's see. G phi phi is equal to negative r squared. Some people hate me for using the plus minus 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 signature, but I like it. There's a lot of annoying negative signs that you could avoid, but I should have done that from the start, but it's too late now. Well, not really, but anyway. Alright, so 1/2 G phi. the negative sign won't matter here. 1 over 2r squared. Derivative of r squared is 2r. 2 will cancel. That's 1 over r. So I'm actually going to write a little bank of Christoffel symbols over here. So we don't have to keep recalculating them. So when you sum over these two, that's 2 over r. So, alright. You actually could, since we're setting each component to 0, you could actually already have this as a solution. It's going to be b over 2b minus a over 2a plus 2 over r. You could actually solve that. I'm not going to do that right now, but you could actually, that actually is enough to have a good solution for us, but we're going to wait a minute. So now we're going to calculate the R component of the Ricci curvature tensor. That was just one of the 4. Okay. Oops. Okay. What time is it? Okay. We're doing good. Okay. Well, that's only the only term there that's going to be important is R. And that's going to be, sorry, I make bad jokes. That's only going to sum over R. And we'll do that part in a minute. It's just going to cancel out. Plus minus 0pr p0r minus rpr prr minus theta pr no time dependence, non-diagonal, only p equals 0 will survive that. Only r will survive that. Okay, no theta dependence, non-diagonal, only p equals theta, and similarly for since those two are equal, we're actually just going to make that minus 2 over r squared. Now, derivative with respect to r, negative 1, negative squared. Okay. 1 squared plus 2r squared. So that 2r squared is actually going to cancel with this in here. All right. Hope I haven't made an error there. If I have, I'm not going to be happy. I don't think I'm doing too bad considering I worked for basically 9 hours in 100-degree weather. If I do make an error, I know the end solution, so. Alright, R's, R and R equals R. I don't need those anymore. Alright, that should do us well for right now. Now I'm going to go to the. Still recording, it hasn't really cut it off or anything, has it? Okay, good. Now we're going to go. For time constraints, I'm not going to go through both of the angular ones. I'm just going to say that r theta theta is equal to r phi phi. It'll turn out to be this way. Times sine squared phi. So we really only need to calculate the r phi phi term, or phi. I've heard it be pronounced both ways, so. There's no, yes, there is some terms with phi dependence. Okay. This one's where I gotta be careful. I'm using a slightly different formalism than I normally do. Okay, so P. None of the terms have any dependence, and it's only dependent upon R. So we're going to do R. P. The only component with any phi dependence is the theta. So we only need to sum over P equals theta. And we already said that that's only going to be R. So minus 0 P theta. That's only going to go over R. Yes. That's done diagonal. On 0. Only need that term. That's non-diagonal. No R dependence. that can only sum over. And no time dependence, non-diagonal, no phi dependence on the time terms, so all those go to 0. Not bad. Alright, how do we go simplifying this? R theta. Well, we already know that right there is 1 over R. So we can just take that to 1 over R. Ignore that. I just need to like glue an eraser to my hand or tape an eraser to my hand. I'll just go. That's just another factor of that, and that's just, so it's going to cancel that. Alright, so I'm going to go ahead and just write that over here. For upload time purposes, let's go ahead and stop this one.